Just like you and me, stars are born and die over billions of years.
Before a star is born, there is only a cloud of hydrogen and dust floating around in space. As the cloud grows larger and larger, gravity starts to contract the cloud into a tight mass, making it denser and hotter. At a certain point, the cloud becomes so hot that the hydrogen molecules start sticking to each other, and eventually, nuclear fusion starts to change the hydrogen into helium. At this point, the star begins to shine. It then starts to grow larger as the vast amount of energy from the nuclear fusion fights against the power of gravity pulling the star to its core. However, at one point, the hydrogen molecules run out, and without energy from nuclear fusion, the gravity starts to pull the star in on itself. Again, the star grows denser and hotter until the helium atoms themselves can fuse together to create carbon and oxygen, once again causing nuclear fusion to happen. The star grows again until it becomes a red giant, which is 100 to 1,000 times the size of our sun. After billions of years, the star grows so large that gravity loses hold of the star's outer atmosphere, which drifts out into space. This outer atmosphere is called the planetary nebula, and it leaves behind only the core of the star. This core is the final stage of a star's life, and it is called the white dwarf. The white dwarf's size is similar to the Earth, but it is 200,000 times as dense. But wait, let's take a step backwards to the red giant stage of a star. Some larger stars form into red supergiants rather than just normal giants. These stars have a different course in life. They continue to fuse more elements together, creating nitrogen, magnesium, silicon, and finally iron. Once the star uses up its iron, it begins to collapse in on itself once again, but then the force rebounds back out in a shock wave, causing what is called a supernova. The supernova is when the star chunks out gas and dust in a bright explosion, dying after billions of years. From here, there are two paths. Smaller stars form into small dense masses called neutron stars, which can be only 20 kilometers across. Larger stars form black holes which suck in everything that is near it, even light.